tonight. First, our main presenting sponsor, Harmonic, which contributed significantly towards the dinner tonight, which I think you probably all enjoyed, right? You like that prime rib? Yeah. And it would be unfair not to say that Teradebt Corporation, which is also a presenter tonight, also contributed to the event as well. And we thank you again, John, for coming down in your company as well. I heard from a number of people tonight that came over to me and said, Botello, my God, your dinners here like really rock. And they do. We like to make sure that the group here is well taken care of, because we know that engineers, whether they be male or female, fight the battles every day on their bellies, and it's good to be able to give you something a little bit instead of just a slice of pizza with a piece of cheese and pepperoni thrown on top. So again, thank you all for coming, and a great thank you to our sponsors for providing the financial wherewithal to make this happen. We have a couple of people new with us tonight, which is why we have the 58. And that is, we have a few probably graduated or graduate students or otherwise from Full Sail University. So I'd like to thank all of you that have attended. Please, let's give it to them. And the reason why, Full Sail just started a student chapter in Smpte, so that's great. So they're attaching to us. It's great to let them come down and be part of our presentations. They get a chance to grow. They get a chance to be part of this great technology, as we all were when we were Utes, when we had like 58 Utes in the program. It was really good. So it worked out really well. So some of the things that we're going to talk about tonight is the success, and I mean the overall success of what we talked about a little earlier, and that's our holiday party. And we put some public for this group, not public externally information on here, because this is a transparency that I want to make sure everyone understands. First of all, the holiday event, 112 people attended. Rock'em, sock'em, dead wonderful. Nobody got out of hand. We had an open bar. It was fantastic. Nobody hit on my wife. It was great. Nobody hit on my girl. None of it. It all went well. It all went well. I forgot. Oh, my son's streaming this. Sorry, Ken. But anyways, so that was fantastic. And we hope that as we plan more and more to get closer to the end of this year and put our next holiday party together, we've learned a lot from this experience. And it was a great event, and hopefully we'll have even more people attend this year. I don't know how that would be possible. We'd have to rent the convention center, but essentially it was a great thing. So with the help of our sponsors, which are the manufacturers out there, we raised enough funds to take care of that. Not only did we raise enough funds to take care of that, but due to the hard work of the managers, which I'll go over their names and their roles here within the Florida section in a few moments, but with the help of our managers that helped raise these funds, we ended up with a positive bank balance, and you can see it right there, $5,029. Now, for some people, that's not a lot of money. For some people, that's a lot of money. I can tell you this, for a section to be sitting with $5,000 in the bank, to be able to do some great things with, both from a marketing perspective, educational perspective, some other materials, it's a great way to start this year. We have Rob McNeil, who is our Secretary and Treasurer, who's sitting over here. Rob, if you could just raise your hand. Thank you. And Rob took over for Mike Poria, who Mike, as you probably all know, if you don't, Mike left our section here at the end of December, most recently to go up to Montreal, Canada, where he decided he wanted to be in the cold and the ice, and he did not like the weather down here, so he is selling snowballs to Eskimos. He's doing a pretty good job up there. But anyways, so in the interim, we were able to vote Rob as Secretary-Treasurer, and he's done a great job in getting our national group to respond to our financial needs, including the transparency of our bank account, which we didn't have before, including setting up a method to pay our bills, which we didn't have before. And this is nothing about Mike. It has to do with national, just a point of information. So that's fantastic. And we're going to go forward this year. This year, while 15 was just a yeoman's year, and there's no way to put it up against anything that was ever out there, either from a section or certainly from Florida. This year, 2016, we met with the managers a little while ago on some issues, and I can tell you we're planning if all goes well, we're planning on making 16 even a better year. So our current managers and duties, and as you can see here, I'm your chair currently, and I work here at NBC Sports and Golf Channel. Rob McNeil, I mentioned a few moments ago, and Rob does an awful lot with asset management here. Great secretary, treasurer, probably one of the most anal people that I've dealt with, in a good way. In a good way. I got a smirk out of him, that's good. Some of the managers that are responsible for programs, which are some of the initiatives that we talked about today, and getting some of the development within this section done this year. We have Ed Cathera, and Ed, where are you hanging out? So Ed's in the back there, if you don't know Ed. We have Rick Trock from Trock Media, who's over there, just raised his hand. And we have on the membership group, which is responsible for generate more membership, is Richard Pearson, who is not with us this evening. I thought he was coming. I thought he was going to be late, but a lot of things can happen out there. And Frank Torbert, Frank's right over there, and Frank is at WKMG, and absolutely their chief engineer and runs all of their operations from engineering. Sorry? No. We have Brian Sluzar. Brian and I have a long relationship. Kind of interesting. I don't let him talk about it because his wife gets jealous. However, he's very deep into web design, web operations, and has been for many, many years, besides all the IT infrastructure. So we've officially named him the webmaster. He's going to create the web of webs for our operation, which is great. And he's also responsible for communications, which is why you see him communicating with the Orlando Air Traffic Control System over there at Orlando International. How you doing? Doing a good job there, buddy? Or is that NASCAR? Thank you. And for event and meeting sponsorship, Don Browning, which we're going to keep pushing Don more and more to get this event in different places. Now, I think that's an important thing for me to talk about, is that it looks like we're always having this at Golf Channel. We're not. Out of the 6 meetings we had last year, 4 of them were not here. So that's kind of interesting. I think people just remember the food, and that's the thing. But of the 6 meetings last year, 1 was held at WKMG, which was our drone meeting, which was fantastic. Another one was held down at Frontline Communications down in the St. Petersburg, Clearwater, Tampa area. Another meeting was held, which we considered and qualified as a meeting, which was at Maggiano's, and we had a meeting at Full Sail. So 4 of those meetings, and then 2 of them were here. So please don't think of this as the only point of meeting for Florida section. It's not. But more so than ever, we want to get it out of here, not for a bad reason, but so therefore we can really get the opportunity to see a lot of different facilities and get a chance to interact with their personnel, their places, their technology, their people, their things, and all of that. So it's a goal we want to meet. Here's the, or negative, however you want to look at it, and that is a term of office for Smpte section, as it would be in any election. I mean, we do this very similar to what they do in Russia with Putin. He stays in for a period of time, he leaves, comes back, leaves, comes back. Only kidding. But when I ran for the chairman's position last year, it was a 1-year term, because that's what the position was open for. They're all 2-year terms, but they're alternating 2-year terms. So those first number of people you see up on the top, it's a 1-year term, which means essentially on July 1st, their terms, or June 30th, their terms expire. So I'm going to talk about that in 1 second. And that's myself, McNeil, Brian, Don Browning, and Richard Pearson. There's a typo here in the second section, which I'm going to correct verbally for everybody as well as otherwise. And that is the 2-year term is Rick Trock, Frank Torbert, and Ed Cathera. So that's the 2-year term that's running right now. So they're not up for re-election if they decide to go on the ballot and be part of this until June 2017. So by opening up elections, I have to tell you here that if there's anyone from this membership, anyone from this group that wants a run, that wants to be considered, totally non-biased, even though it has to come to me for purposes of submission to national. If you want to run for chairman, if you want to run for one of the managers, if you want to run for secretary treasurer, you can. You can. This is not Russia. This is not Donald Trump and Bernie Sanders. This is, and I'm not giving any political views, I'm just saying this is your section. So, yeah, I do intend to run again this year. I've only been doing this for 1 year. I think we've been successful. I don't want to talk about promotion, self-promotion. That's not the point here. But I am saying, and I stated to my managers earlier, that I don't plan on doing this in perpetuity. I want people to have the opportunity down the road, should that work out, or next election, whatever, have the opportunity to share their likes, their dreams, their vision, and their drive with this group. It's been so successful up to this point right here. But if you have an interest, get your information into me, and the reason why, by Monday, I have this email here from National. By Monday, March 7th, I need to submit to them those individuals that are considered being for these offices, with their headshot along with a completed candidate. So please, you should know my email address, and it's all published everywhere in the universe, and we'll make sure that happens. So that's that. Questions? One of our last points here. This year is the Smpte Centennial Celebration. Smpte Centennial Celebration. Smpte has been in existence for 100 years. This October, September, October. So expect a lot of things from your national group to come your way in email or other direct mail, exciting you, influencing you to be part of that. They're soliciting big dollars from major companies. They got a lot of funding from different companies, and that's great. They're not looking for dollars from the membership here. But I'm just letting you know that we're going to be asked to maybe do some testimonials for them if that works out, and some other materials. You're probably going to see a different logo on letterhead. I didn't want to unveil it tonight, but it's the Smpte 100 logo. Many of you have seen it everywhere and what you get from their mailings, et cetera, but that's important this year. So, two great presenters tonight. We're going to start off our first presentation with Teradebt Corporation. We have John Landman, who's Vice President of Sales. John has not presented at 100. It's a direct sales approach. It's a technology approach, which is the important thing, but he's got some great product. He wants to talk about why that technology works and what might be of interest to you. So, John, please.
Be gentle with me. All right. How many of you guys have heard of Teradebt, used any of our gear? Okay. Bolts, beams, cubes, slices, T-Rexes, all of the above? Okay. Okay, so I'm going to start off from probably the simplest products that we make, which are our 5 gigahertz uncompressed wireless transmitters. They've become very popular in using in studios and also out in the field. They are in the 5.8 band, which means that you can run into certain frequency problems, but we recommend that you use the patch antenna. I am not plugged in. Can I be? Can I take this out? Okay. All right. Yes, they are. That's a good point. All right, there you go. So we make these guys in 3 flavors, right? 300 feet is very popular inside a studio. Range, as I said, 300 feet. Can it go through walls? It will go through a wall like this. It won't go through a cement wall. One of the things to note on it, though, is that it has an internal antenna. The internal antennas are about an inch below the tops of each devices. And you've got to be careful when you mount those on your cameras that you keep them as high as you can. I've had people use them and then turn around and realize, they're blocking the signal. On the both 600 and 2000, we use external antennas. As you can see, these are omnidirectional antennas. What does that mean? I was doing a demonstration in a studio a couple of days ago. I had 7 training sessions over 7 hours. And in the studio next to me, they were playing the Adele song every 5 minutes. I was about to kill myself. Okay, the point being is when you use an omnidirectional antenna, you're basically listening to all the noise around you, right? I was hearing that noise from Adele, and I just couldn't think about anything else about putting down the phone. Anyhow, so when you use a directional antenna, you're going to face it in the area that you're trying to get the transmitter to send you a signal from, and you're not going to hear the noise from behind you. So you're going to get a far more resilient signal. The patch antennas look like this guy, and we supply those. You put them on a truck, you put them on a light stand. It enables you to focus your signal in a particular area. I've had customers use these in various different ways. U2 used them on stage in their concerts because they wanted to have a wireless camera on the stage. Again, what they're trying, even though the control room was, half a mile away, what they're trying to achieve, and this is what you have to think when you're doing wireless, is what are you trying to do? You're trying to get a cameraman to be able to run around in a certain area that you want to get a feed from, whether that be a stage, whether that be a studio. And as I said, the control room may be miles away. So how do you get around that? What do you do? Well, I did an event at an NFL stadium the other week where the control room was up the top of the bleachers and around the corner. And what we ended up doing was running a couple of 100 feet of cable to the sideline and basically putting the patch antenna on a tripod, and we covered the whole game. That's some ways you can alleviate the problems of interference, right? We are not in the 2 gig band or in the licensed bands, right? One of the reasons that we went for the 5.8 band is that kind of technology means you can go anywhere with it. It's very cost effective to make radios in that area as well. Some of the other, and I don't know if I mentioned, but all of our Bolt family are both HD SDI and HDMI in and out. So they do conversion whilst transmitting. One other thing that we've just added to the Bolt family are LUT lookup tables in the receivers. You guys know what LUT lookup tables are? Color correction. Sometimes you need to paint or add an effect or add a color effect. That's now built into the receiver. So if you're trying to paint a particular look on a particular camera that you're trying to match with other cameras, the Bolt's a very good way of doing this. Something that I did for NBC Sports up in Connecticut, they were shooting with a red. Do you guys shoot with red at all? That camera outputs 1080p 60. That's no good for you guys. The Bolt will convert wirelessly from 1080p 60 to 1080i or 720 wirelessly. So that's also a great feature that has been built into the units. We make other wireless products as well. A family called the Cube that looks like this. Yeah, let me find the Cube. All right, that's our little Cube. This is a true story. We came out with the Cube about 5 years ago. I took it into the first TV station that I was working with. It was actually an ABC station in LA. Anyone from LA? Anyone know John Holland at KABC? I handed him this unit. He couldn't quite make out what it was, but I plugged it onto a camera and I handed him an iPad because we can stream wirelessly to an iPad. We turned an iPad into a monitor. He said to me, now I got a reason to buy an iPad. He didn't care that it could stream wirelessly to an iPad, but back 5 years ago, the iPad was the thing to do. So back then we had about 10 frames of delay. Actually, what we do is we take in HDSDI and we encode into H.264 format up to 10 megs per second, and we output that in a protocol called RTSP, which is a protocol that we can send to an iPad. We have an app that you put on the iPad, and today we're doing that in about 3 frames of delay, and we're actually doing that as a quad view. So we can do a quad view on a single iPad with the wireless transmitter that these cubes output. And it's now being used, behind the scenes. We did it behind the scenes of The Voice and the Academy Awards. They actually used a cube to wirelessly stream the prompter onto an iPad, right? Very easy way of getting a wireless prompter out there. So the cube also outputs transport stream. You're familiar with transport stream? That's the protocol that enables you to send a signal over the public internet. And as you can see on the cube, we have an Ethernet connection right at the back here. And it was actually TMZ said to me, can we send an output from one of these cubes, not just wirelessly, but also over the public internet? And we started, and we did. And we started using cubes to send signals from point to point over the public internet. And we encode up to 10 megabits per second, and it's used with our decoders that output HDSDI at the other end. I have a customer that actually used to work for NBC, a guy called Jeff Gaspin. Anyone familiar with him? He used to be the chairman, and he started an over-the-top internet-based television show, and the first customer that he had to do this for was a lady by the name of Sarah Palin. So we were sending these devices up into her home in Alaska, but one of the problems we had there is that we could only get about a 3.5 megabit per second connection over the network feed that we were getting, and we needed about 7.5 megs in order to have a quality that we could put on air. So we developed a product that you may or may not have seen, which is our bonding solution. So what we did in Sarah Palin's house was plug in a couple of cell modems plus a USB to Ethernet adapter, and we ordered two internet providers to supply us network connections. So we were bonding 3.5 megs from each provider plus cell, and then sending them back to the control room in LA. Okay. They didn't want to run up to Alaska every time there was an issue, so we had to make them a remote control system. So we developed this thing called Core, which allowed them to basically select any one of their feeds from these encoders and route them to the decoders by just dragging and dropping. What they were also doing was recording in the cloud by just pressing record, and then saving the files in the cloud so that they could immediately put those down or bring those down into an editing format. You guys edit with ISIS here, right? So what we've done for a lot of post-production companies is take the output of the... They're taking an output of an Avid, sticking it into a cube, sending it up to the cloud, and allowing executives to sit at home and watch with about a second delay what's going through the editing station. So where does wireless fit into that? Well, we're streaming that wirelessly from the Avid into the Wi-Fi network using a cube, right? And then up into the public internet, and then pulling it down to the TV in the executive's house into a cube decoder that we're just routing it this way, and then allowing someone to view exactly what's going on in an editing session. One other thing that we can do with our encoders is send feeds. Let me find that. Here we go. There we go. To multiple destinations at the same time. I can just continue to drag and drop. So I might have a customer in London that needs to see a feed, in New York that needs to see a feed, or, as we are doing here, we want to stream something that we're routing as well. So basically, I can drag and drop a CDN destination directly onto my encoder and remotely start and stop a stream. Now, something that's nice about this system is that we can send to multiple CDNs at the same time. Anyone ever said to you, what's better, Ustream or Livestream or, any other CDN? Well, with this system, we can go to unlimited number of CDNs. Any questions so far? None. Of which product? Okay.
What was the question?
What was the cost?
I can't discuss it.
I can't discuss it.
Sorry. You can talk to him, yes, please.
Okay.
You can do that afterwards.
Now, we start at about 256K, and we go up to 15 megabits per second. We actually use adaptive frame rate encoding so that this core talks to the encoders and measures the bandwidth that it's getting over the public internet and will increase or decrease based on the statistics that it's seeing. You can actually see that here, that I'm looking at the bandwidth that I'm getting here over this stream. Here we go. Let's refresh here.
What's your delay between transmit and receive?
If I had a cube encoder here and a cube decoder here and I connected them wirelessly or over an Ethernet cable, I have 4 frames of delay. Over the internet, quite typically, it's about a second. Okay? We actually started doing wireless cube-to-cube on set before we came out with the Bolt. The reason that we came out with the Bolt is because for a lot of people, 4 frames is too much. Have I lost my network connection? Oh, well. I think I have. Anyhow, so I can tell you that we have been used to back up the Super Bowl. I have an NBC station in Denver that had a truck last year at the Super Bowl in New York, and at halftime, their uplink truck lost lip sync with their encoder, and they switched over to a pair of cubes doing 3.5 megabits per second, 720p back to the station, up converting it. The cube decoder up converts it naturally to 1080i. They switched over, and no one noticed. So we were very happy with that. But we are here to talk about wireless, and I don't know how much time I've got, but as I said, we have cubes that encode H.264, transport stream RTSP or RTMP up to about 15 megabits per second that can stream either to a decoder wirelessly, either to a decoder on the other side of the internet, or to a CDN. We have the Bolt family that does 0, 300, and 600 feet, uncompressed, 0 delay. And recently we came out with a product called the Beam. All right, question for you guys. If the cube at 4 frames ran away and had a baby with the bolt at 0 frames, how many frames delay would the love child have? 2 frames. Exactly. If the bolt is uncompressed and the cubes are highly compressed, love child would be lightly compressed. Okay, so. No, because, never mind. Right. So we actually, the beam is actually in between the bolt family and the cube family. Why am I telling you this? Because people always ask me, what is the beam? Okay, so it is the love child. But it did inherit something from the bolt, which is a range of 2,000 feet. The cube to cube range, because we're using the Wi-Fi, 802.11 Wi-Fi AC, we get about 300 feet. But then there is a little trick that the cube has under its belt, that I could join the Wi-Fi of this facility, right? We talked about this earlier. You want to go anywhere in this facility and be able to get back to your control room. Well, one thing that you have here, ubiquitously, is a Wi-Fi network. So basically, I could put a cube on top of a camera, join the Wi-Fi network here, have it point to an IP address that's in the control room of a cube decoder there, and with about 4 frames of delay, you'd get that image back there, right? So you can think of some very useful uses for these devices. But let me get back to the beam. So the beam has 2,000 feet range as well, and we find that it's more broadcast-centric because it also has bidirectional IFB. The bolt doesn't have IFB. The cube has unidirectional IFB. What does that mean? So as I mentioned, I've got the decoder in the control room here that's connected to the network of this facility, and I have a cube encoder on top of a camera that's wireless running around the building here. Well, if you look on a cube, you'll see that there's a headphone jack. That headphone jack is because you can talk from a decoder through the network wirelessly to an encoder's headphone. So we use that as a unidirectional IFB. Any questions? Okay, camera control. That's an interesting question because the beam actually has an Ethernet connection as well, and we can pass the Ethernet connection to the wireless. So in theory, if your camera has an Ethernet control, which the newer cameras do, then we will wirelessly be able to control the camera, okay? We've done this with certain PTZ cameras. We've done this with Reds. We've done this with Alexas. And we're starting to do it with some other cameras, some Canons, and I think Panasonic's coming out with an Ethernet control. They have an app, right? So if the app can control the camera, then we'll wirelessly pass that app information because it's just a wireless network. Something that we recently just released was a product called the Teradek Color. What is the Teradek Color? Any DITs here? This is a wireless LUT box. And I've seen it used in broadcast because how many of you have had to use a GoPro or action cam and mix it with broadcast cameras, right? This guy takes in HDMI, converts it to SDI, and adds a LUT to it. These LUTs can be created by a DIT that understands color correction and painting and can load that LUT up wirelessly on the fly to match your broadcast cameras. I had a scenario the other week, again at an NFL stadium, where they wanted to use a simple PTZ camera in the broadcast. And these PTZ cameras, they don't have a way to paint the cameras. You don't have controls like you do with the Sonys with the CCU controls. So they connected this guy up to the wireless network of the facility, and what they actually do is created a bunch of different LUTs based on where the sun was, because In the beginning of the day, the sun was over here, and at the end of the day, it was over here. So that's what they're starting to use as well. And that can also do camera control. So we can do wireless camera control, HDSDI conversion, and add LUTs. Last but not least, if we're 2 minutes, if we're gonna bring our last wireless piece of gear in, then this is wireless, but over cellular networks. As I mentioned, we do bonding. Why do we do bonding? On a cube, we have a single USB connection here. So I can run around and get one of these 4G modems, put it in here, put it on my camera, and not just connect to a Wi-Fi network, but also connect to a cellular network. That's great if you have good cell connection, but as one chief engineer came to me, he said to me, single 4G just doesn't cut it. So for him, we actually created this product, which is basically a cube with a bonding device on top, and we can aggregate up to 6 cell modems. Now, you're probably all familiar with bonded gear. There's LiveU, TVU, the Gero, right? This is a very similar product, something that we've been selling for 4 years. But I'm going to tell you about a technology that we're releasing in the new cube at NAB. This is the new cube. This is a H.264 encoder, similar to the old encoder, but it's got an extra FPGA so it can run apps inside. We've created an app called ShareLink. What is ShareLink? Well, USBs are being abandoned by the providers. They're becoming harder and harder to get, plus they're harder and harder to manage for you guys because you have to subscribe to them, you have to manage who's got what and when. So what does this app that we have built into this unit do? It's called ShareLink. So we have an app that you download on the iPhone called ShareLink, okay? This has wireless, it acts as an access point. So I stick it on top of my camera, we get to an event, I got no Ethernet connection, I can't join the wireless, so I tell you, up to 6 guys here, pull out your iPhones, open up the app, and enable ShareLink. The ShareLink will find this device. This device has the intelligence to bond up to 6 phones together and use the combination of that data to get a feed back to the control room. We're calling it Friends with Bandwidth. Okay. It's the future of bonding. It's wireless bonding. I mean, we can also plug modems in here, but this is bringing bonding. This is bringing bonding down to the point where you could put one in every cameraman's kit, and when they go out, you can light up cell phones and just bond and send the feedback to the station. The nice thing about our control room, which I didn't mention, I'll be very quick, but our switcher in the cloud, right? We make bonded gear, we make rack mount gear, we make cubes. All of those for us are sources. So it means I can take any one of my sources and send to any one of my decoders, which means we're not just routing wireless gear, but we're routing wired gear as well, which I think differentiates ourselves from other encoder manufacturers.
John, I need to unbond you right now.
Okay.
Thank you.
Thanks.
Thank you. Yes, please.
The ISP section, how much delay is ISP coming back?
Where? Over the public internet or? Where?
Wireless and in
Another
another location.
location? Well, because that's such low data rate, and we're sending it on a different channel, we're not bonding that, so we don't have to debond it. So it's going to be about a half a second.
Then part 2, just like live view, like when you're in a crowded area, bandwidth starts fluctuating.
Yes.
Resolution is usually, how many cubes can you put in a live environment?
Cubes or bolts?
Cubes.
Well, cubes are just joining the Wi-Fi network, right? I mean, I got 30 running in the office. Yeah, I mean, we're compressed, right? If you're talking about bolts which are uncompressed, we can put about 4 in the same studio. Thank you.
One more question. Go ahead, Larry.
Right, can you repeat that?
Is it duplex?
On what product? Yeah, well, the bonded product or the cube we're sending up to the cloud, we have a way that you can pull down a feed at the same time as a return feed. I can explain that to you in more detail if you wish.
You will tomorrow, because he'll be in your presentation.
There you go.
Thank
Thanks.
you very much again, John.
Thanks.
Appreciate it. So just as a point from the chair position here, we let John have a little bit of yeah, a little bit of leeway, but normally to talk about specific product, we normally wouldn't allow it, so I apologize for that, but it sounds like there's a lot of great questions out there. And just as a point of information, because we are looking very strongly at this product line, John is presenting to our engineering group at NBC Sports Golf Channel tomorrow. Now, to be fair about everything, there are a lot of products out there that do similar. So we're looking and we're researching into a number of different antenna arrays that are available out there, reception capabilities, and different codecs that are being used, whether it be compressed or uncompressed, and so forth and so on. So I just have to throw that in there. So anyway, that being said, we have our next presenter, which is Michael Guthrie from Harmonic. And Harmonic's been around for a while. For some of you that don't know it as the name Harmonic, you know it also as it used to be called Omnion, which was great, and it's still called Omnion to a great degree. But sometimes when you go to NAB in the booth, you're looking for the Omnion booth, and you go, "Where's Omnion?" Oh, it's Harmonic. But essentially, same thing.
My harmonic used to be called Divacom.
Oh, yeah, gosh. Oh, my God. Yes. That's when pigs flew. No, I'm sorry. There's your arrow to go forward, and there you are.
Ah, perfect. Okay. So I'm actually filling in for, I think, the original advertised presenter, who's my one of my counterparts, Scott Woods. So, you know, this is actually his deck. My specialty tends to be more television stations and satellite distribution and all that, but I'm reasonably conversant in this. Just to give you a little bit of background, in the 70s I was in the music business. In the 80s I was with ABC. And starting in the 90s forward, I've been working for manufacturers, usually as an engineer or in sales or something related. So just as a background, I've seen a lot of changes, put it that way. So what we're going to talk about is, and I'll go back a slide here, we're really talking about over-the-top internet video. So go to the complete opposite end of where the programming goes from what we just heard about. And so now we're talking about delivering program to viewers. And of course, we're all used to cable or broadcast or maybe DirecTV or something like that. Over the top is a whole new area. In some circles, it's on fire, and in other circles, it's moving very slowly. But I'm going to talk a little bit about the technology of how this works. And maybe along the way, I'll comment a little bit about how it's going to affect people who are primarily in the broadcast side of things, which is where I come from. So if you look at the video market today, there's a number of factors going on. One is that there's an explosion of content. There is so much content being created now, much more than in the past. Along with that, there's consumer behavior is changing. So like my kids who are, college age and a little older, don't really watch TV much. They mostly watch on a pad or on a computer. So there's a lot of changing behavior on the consumer side. The other thing is that the number of hours being watched globally is actually exploding. People are actually watching more TV than they used to, not less. It's just that it's a wider variety of television and maybe some kinds of video content that you might not call television but effectively are. And along with that, the monetization of this content is both shifting. So, the old traditional model of, well, I watch a show and about every 10 or 15 minutes I see a commercial that, 20 million other people are seeing. That's shifting towards new methods of deriving revenue from this video content in these productions. And finally, as a result of all this, a lot of the legacy distribution models, the ones that I've always specialized in, are being disrupted. And this is going to be an ongoing process, certainly for the rest of my career. I'm older than a lot of you guys, so that may be limited. But so there is a disruption of what's been the traditional video consumer market. And, so finally sort of wrapping it all up is, there's strong demand for video, but the traditional models are changing. So in terms of the content explosion, content for pay TV is increasing dramatically, for cable delivery, along with content being created for Netflix, content being created for, Amazon, all the different ways that people are getting content. So there is just more content being created. This actually is an old statistic. 50% of consumers watch streaming content. It's really now about 80% of consumers are watching some form of streaming content at least once or twice a month. And, the other thing is that there's actually not necessarily a lot more places producing content. So, there are, in terms of cable content, there's actually more content being created by fewer players for the traditional roles. When you get outside of that, then maybe that changes a bit as well. So this is, there's a media disruption as a result of this. So, looking at this, people do acknowledge the content is better today. And you can't necessarily look at one specific show and say, well, that's better than it used to be. But across the board, there's more high-quality content available today than there ever was before. If you look at various customers in various places, the trend really is that there's investment in content, increasing investment in content. At the same time, a lot of the traditional players are having to reduce the expense of producing content. So operating expenses are being reduced. And at the same time, they're finding new ways to monetize content. So again, it just points to a disruption in the traditional pathways of delivering content and of how people watch content. So, just if you follow the news, there's various, there's all these statistics about cord cutters and cord nevers and, what the eventual consequences are. So some of the traditional players are going to suffer. I mean, if your business model is to collect $5 or $6 a month from every subscriber in every cable TV system, there may be trouble ahead in the water for you, And so in a lot of those companies, there is a drive to reduce expenses and at the same time a drive to increase the number of ways that content can be consumed to drive more value from more different operating points. So that gets us to the topic, which is really over-the-top television. And by over-the-top television, what we really mean is we're delivering the audio and the video, you know, over the internet, where it's not a dedicated infrastructure. So, you know, it may be coming in on my cable connection, but it doesn't really matter whether it's a cable connection or if I go down to Starbucks and hook up to the Wi-Fi or whatever it is. It's not attached to a particular service provider. In general, it's delivered by regular internet protocols, and it uses the open internet and unmanaged connections versus what was traditionally IPTV, say with a telephone company, where it's being delivered by internet protocol, but it's over a managed network. So your traditional IP delivery, and you know, this could be, you know, a telephone company delivering over DSL. You know, I had customers, you know, several customers that I worked with who took that method. Generally, that's a constant bit rate delivery. If you look at older streaming methods, generally speaking, those were a single stream delivered at constant bit rate. You know, if your computer can't keep up with it, then it pauses for a little bit and it catches up, you know, that sort of thing. Or if you're watching on a DSL connection and for some reason it can't keep up, well, you just lose the signal. So, you know, that offers a, you know, it's very often a multicast, you know, but it's a continuous stream. And the real issue with this has always been that you have to guarantee a certain amount of bandwidth in order for the user to actually have a reasonable experience. So when you choose the bit rate of the video that you're going to send, if you use a lower bit rate, the quality suffers, but more people are going to be able to see it. So when we move to the multi-screen delivery using adaptive streaming, and adaptive streaming is really the dominant technology for over-the-top delivery, what we now are doing is it's a unicast connection. In other words, your device is going to receive its own stream. It's not the same stream, even if I'm sitting next to you at the table. You're getting one stream from a server, I'm getting a different stream from the server. It may have the same content in it, but each one is unicast just to a specific device. It's also chunked, and by chunked, what we mean is that when the video is encoded, it doesn't leave the system as a steady stream. What happens is it's broken up into these little pieces, and each little piece is actually a file, an individual file. So when I pull out my iPhone or I pull out my Android phone and I'm watching video, I'm not actually watching a continuous stream. It appears that way to me, but what's happening is my device is going out and fetching these files one after another, and then it's playing the file back. And there's a number of things that fall out of that. I'll go back and talk about this just a little bit more before I go on. So one of the advantages is that I don't necessarily have to download the same chunk as the guy next to me. So when we encode this, what we can do is, you know, we can have a selection of different bandwidths. So if I'm on an iPhone and I'm in a weak reception area, I may get a very, very low bit rate version of this. And my phone knows which ones to download because it knows how long it takes to download each chunk. And if it can download a higher quality chunk, it'll start downloading those and playing them. If I walk into the other room and the signal drops, it can download a lower quality one. So I get continuity of experience. So in terms of the protocols, there's really four widely used. The fourth is arguably not terribly widely used yet, but is going to be, at least we believe. So Apple has their version called HLS. Microsoft has a similar one called Smooth Streaming. Adobe has dynamic streaming. And then there's MPEG-Dash, which is a standards-based version, which actually can be similar to any of those. And they all operate on the same principles. So looking here, basically, you start out, let's see, there is a laser on here somewhere, I believe, on the side. Oh, red button in the center. Okay. So we're going to start out, and like, if you're watching live, we're going to start out with an encoder. And this encoder is actually very similar to the one that we use when we make cable television or satellite television or anything like that. The difference is instead of only encoding at 1 bit rate, it will encode at a whole bunch of them. And typically, it's anywhere from maybe 3 or 4 up to as many as maybe 15 or 20 different formats and bit rates. Those different streams then are fragmented into these individual chunks. They can be encrypted, and then basically the chunks, these little 1 to 10 second files, okay, and whether it's 1 second or 10 second, there's a lot of variation according to which system you're using, and in some cases you'll change that according to how much delay you're willing to tolerate. There's a whole bunch of reasons for deciding different chunk sizes. And then eventually it gets to a web server. And those chunks get deposited on that web server exactly the same way that you put a photograph onto a web server. So it's just sitting there on the disk, and it's waiting then ultimately for the client out in your phone or your iPad or your computer, or increasingly your television set or your Blu-ray or whatever, to ask for those files so you can view the video. So, but now what happens is, not all devices work with all of the various formats. So some devices might work with, Apple, but might not work with Silverlight. And other devices might want to work with Adobe, but not with one of the others. So the first thing is that most of the time, if you want everybody to be able to watch your video, you're going to have at least 2 of these running. Okay? So all of a sudden now, you've got twice as many different files here. Okay? Because once they're wrapped, once they're wrapped and chunked, they're unique to a particular brand of distribution, if you will. So before long, this web server is getting a lot of files. I mean, really a lot. And it's a lot to manage, and it's a lot of storage. And then at the other end, generally speaking, each player is tied to one of these systems as a format. So if you download a specific player for a specific, source of content, it will usually be tied to one of these. So again, we just end up with a lot of different variations of effectively the same video. So looking at it here, I'm not going to go too deeply into the differences. They all work similarly. If you look here, HLS is actually packaging up a transport stream in the file. Microsoft and Adobe make it more of an IP-based MPEG-4. None of that really particularly matters. It's just files that you're downloading, and it matters in the detail of how it gets decoded. It's very, very similar across all of them. And so those everything gets packaged. Dash, which is the standards-based one, actually can do either of these. So, after they're packaged, they go to the CDN, and that's where you generally will pick it up. So now, if you want to look at the various bit rates that get used and formats and all that, if you start out, at the low end, you're going to have phones, which generally, the lowest bit rates will be a low frame rate along with a low video resolution. Some phones now, though, actually have high definition screens. So the resolution increases up there. And don't forget, there may be 4 or 5 different formats within this range. Then there's sort of an overlap with tablets, which will have both higher frame rates and higher resolution. Eventually, you get to connected TVs through gaming consoles, and increasingly connected TVs without the gaming console for a Netflix or an Amazon feed or whatever. And then eventually you get to the broadcast TV formats. over the next year or so, there's going to be an extension up here as you start to see ultra-high definition content. And really, the early delivery of ultra-high definition content, a lot of it is going to be using these kind of standards. Because currently, there just isn't very good ways to send it over cable or satellite yet. There'll be some of that, but the most practical delivery right now is over the internet. So looking at some of the challenges, I'm going to touch on time shift services, but essentially time shift means you've got a live show, but people are going to want to tune into it later on and watch it. And for that, you need wrong button. For that, you need an efficient infrastructure because you're going to have to save all of that content in all those different formats so that somebody can tune it later. And that leads, of course, to an explosion of different formats. You got to make money on it, so you're going to have to insert ads. And the bandwidth is not insignificant. The cost of transmitting all of this, the peering charges and the serving charges, it's not an inexpensive way to send video necessarily. So looking at some of this, you have, what we call a start-over service is, you've got live content coming in and you're sending it out and the client is watching it. But the client may actually want to be able to look at that later on. So one of the things you can do then is you can save out all these files into storage so that later on you can go and you can rewind back to the start of the program and watch it over again, or you can pause and go to the restroom, or if you joined the program and it was already partway through, you can go back to the beginning and watch it from the beginning. This is very resource intensive to do this, to make that available to every viewer. I mean, you might have 10 million viewers out there, any one of which can stop, fast forward, rewind. It's a very hardware intensive, resource intensive thing to do. There are some ways to make this a little less intensive. One is called packaging on the fly. So normally you think of, you create your files in a transcoder or an encoder. You're going to package them up. You're going to scramble them because, you don't want everybody to be able to watch this. They've got to be encrypted so that, you might have to subscribe to this. That'll then feed an origin server and eventually get out to the client. But at this point now, you've got that plethora of different formats in all those different files. On the other hand, if you go the other way around, what you can do is you can transcode now and create your group of various formats, which might be 8 or 9 instead of 80 or 90, right? You can save those in storage, and then when somebody requests the file, you package it for them dynamically on the fly. So now your storage is much less. What you've done is you've shifted a lot of load out of here and put it into the packager and the server. But that is becoming sort of the norm for anything that's going to be stored. So basically, you save storage costs and all that. Mind you also, if you're storing it for the long term, there may be a new device next year with a new packaging format. So if you've already got the files, but they're not packaged yet, you can reuse all those files that you've already made directly. All you have to do is set up the packager to be able to use the new format. So again, talking about monetization, you have, the amount of money that's going to be spent on ads is increasing. And, it's like live television is, holding its own, but the internet has has diverted a huge amount of money from that. But eventually this all starts to sort of look like one universe of video ad sales. So, ad insertion into over-the-top is going to become an incredibly important thing. And, you know, there's a technology that's been around for actually quite some time in cable for inserting ads called Smpte 35. This is a standard that's been around for some time. It was extended in 2013 to add more capabilities. And this is becoming widely used as a way to mark the points in the stream at which you can replace a commercial. And in cable, it always worked, you know, you send it up to the satellite and it comes back down, and the cable company gets to insert their commercials twice an hour or whatever it is. And Smpte 35 marked those positions, and then the cable company would replace that, and all 9 million viewers in New York got the same ad from the cable company. And later on, the cable company maybe regionalized that a little bit. But when you go OTT, that can be regionalized down to individual viewers. And the extensions in the Smpte 35 provide facilities for describing things about how you would insert that ad. So the ad insertion, you can look at, there's a couple of different ways you can do it. So you can insert it in the packager, meaning the packager is probably now taking those raw files, packaging them up, and creating a stream for me. And so I can insert it there, but it's very intensive compute process when this packager is having to do, you know, really, really large numbers of streams. So the most common alternative now is really to set up the stream so that the actual insertion happens on the device that you're watching on. So essentially, and I've got a slide coming up actually that's going to talk a little bit more about that. But essentially, you mark the beginning and the ends of the content, and the device then. So basically, the file, you know, you're sending the streams out either, you know, with one of the multitude of formats. Essentially, what you're watching usually originates as a manifest, meaning I go to my player, and there's a browser in there, and I'm going to select a piece of content. And my player goes up to the cloud and says, I want to watch that content. And what the cloud does is send back a list of the files that it takes for me to watch that content. So it's not pushing the files to me. I'm pulling the files to me based on this list that's being sent down to me. So it's a relatively straightforward process to modify that list on the fly. So when it's time to play a commercial, you basically send down a new list that says, okay, so this is the next group of files that you're going to do. And all those edge points are marked by these Smpte 35 commands. So now what you've done is you've taken the load off of the central server and put it down in your device, which scales along with the number of viewers. It's also your device is the one that knows who you are. And don't forget, this is really where the money's going to come from, okay? You know, used to be that you made money, you know, you ran a Bayer aspirin ad, and, you know, all the people all across the country watched it, right? But now, you know, they can figure out what kind of ad I might want versus what kind of ad somebody else might need. It's not necessarily a bad thing, because there's some ads that I just have no reason to ever want to see. And then there are other ads that are, you know, more appropriate for me. So there's this convergence between broadcast and this over-the-top delivery. And there's a lot of broadcast right now that's not available for over-the-top, mostly because the rights aren't there. It's a very, very long process to take all of the content that everybody's, you know, geared up to transmit, you know, over all these years. Most of the time, there's no right to just send it through a totally alternative path. But over time, that's evolving, and more and more broadcasters are making their content available as a stream as well. And more and more broadcasters are actually embedding the Smpte 35 that it takes to do OTT delivery, embedding that into the broadcast as well, because I can tune in on Cablevision where I live, and I can watch all the broadcast channels as long as I'm at home. I can watch them on any portable device within my house. As time goes on, more and more of those will be available. If I just bring my tablet with me, I can watch in a hotel. Relatively few of the streams are available that way now, but the number is increasing every year over time. And that's really not technology driven, that's rights driven. So, a little play in here for harmonic is that one of the things that's coming out of this is actually encoding is pretty important in this. And there's a number of reasons why. The first is that it costs a lot of money to send video over the internet. You have to pay for every gigabyte you put out over the internet, you're going to have to pay for. So if you can reduce the bit rate, you'll pay less. There's another advantage to reducing the bit rate as well, though, which is that most viewers can't get the maximum bit rate. If I'm sitting in Starbucks and I'm watching on my tablet, I'm not going to get the same bit rate that I get when I'm watching at home. So for a given bit rate, as we improve the encoding quality, then you will get a higher quality signal wherever you are, possibly at a lower cost for the content owner who's sending you the content. Key to a lot of this is a new codec called HEVC, which is just really starting to get legs under it now. HEVC basically, if you look at the progression I've been in the encoding business now since 1998. I started out with MPEG-2. We eventually got MPEG-4. MPEG-4 for the same picture quality, more or less half the bit rate. HEVC is about half the bit rate of AVC. So it's about a quarter of the bit rate of the original MPEG-2. I might add, though, that MPEG-2 now is less than half the bit rate it was when I started for the same video quality. So, when I started out, you kind of needed about 17 or 18 megabits to make an HD picture. And now we're doing 3 in that bandwidth. We're at about a third. Arguably, we probably could do 2.5 to match the quality that we had originally. But round numbers, it's about twice as efficient as it was when I started. So these quality improvements come in over time. And HEVC, like everything else, what I expect will happen over time, and this applies to, over-the-top delivery, this applies to broadcast delivery, it doesn't matter, it's all the same codec. Over time, all three, MPEG-2, MPEG-4, and HEVC will all decrease in bit rate beyond, lower than where they are now. And that will reduce the cost of delivery, and it will improve the user experience. HEVC is really the key to ultra-high definition, because without it, nobody's going to have the bandwidth to deliver it. But with HEVC, you can actually deliver a UHD, 4K picture in less bandwidth than we delivered the original HD in MPEG-2 in the old days. So just, there's, all this news, we're part of it. There's a lot of consolidation going on in the industry. And that's driven by a number of factors, not the least of which is that, all this technology is costing less, not more. So, it's, even though my company sells more dollars worth of encoders than we did in 1998 by far, we're having to sell maybe 20 times as many to get to the same dollar. So, so there is consolidation, if you follow it, there's combinations, Elemental being bought by Amazon. Ericsson has acquired Invivio, one of our competitors. We're just about to finish acquisition of one of our competitors, Thomson Video Systems. So there is a continually changing, marketplace of suppliers in all of this. And I have to say, we have some very, very good competitors. We have competitors that definitely keep us honest. Along with this is we have the trend to gigabit to the home. So it's not just Google Fiber. Comcast has announced that they're going to do it with DOCSIS 3.1, and I believe they have pilots running. I believe that the 5G standards, that are coming out for cell phones are going to get close to that wirelessly. So again, the ability to experience content this way is going to grow astronomically for people. You're not going to necessarily have to have a wire in order to watch UHD TV, within a couple of years. And then finally, just there's ongoing news. If you follow all this, there's this statistic: 78% of viewers watch video online. It's 213 million viewers in the U.S. Watch video some way or another. I saw a really interesting statistic on that, though, which is that when you take like Netflix viewing, there's a really, really a large number of Netflix views that occurs on cell phones and tablets. Interestingly enough, all but about 10% of them occur in the home. So people are walking around in their house with their iPad watching movies, more than they're watching at Starbucks. So there's a lot of trends to watch in all this. It's going to be a changing market. If you're a broadcaster, it's going to affect you. It's going to be part of your business, whether you like it or not, basically. And that's it. Questions? Sure. Commenting on the battle between HEVC and VC9, if you remember, there was a very, very similar battle when AVC came out between AVC and I believe it was VC1. So it may turn out to be really, really important, or it may end up like, no one knows about VC1 now, right? It's all AVC. So I think, part of that battle is that if you're in the business, if you're Google or you're Amazon, you want to make sure you have a codec available that's not going to cost you an arm and a leg. So I believe that most of that is really about licensing costs. If the licensing pool, doesn't do the right thing, an open codec could take off. By the same token, a lot of smart people are involved in developing HEVC, and it is a very strong, encoding engine. So, if the licensing issues are straightened out, it'll dominate. If they're not, it may not. Questions? Other questions?
Thank you so much, Michael.
Thank you, everybody.
Great presentation. So, we actually have a couple of one is we'd like to form, we were talking at our managers meeting, we'd like to form some committees out of this group. When I say out of this group, out of our general membership, but certainly out of this group first, because you're here. We'd like to set up some subcommittees, a technology subcommittee that can help us a lot in picking out technology that we want to present with us and work with our managers at doing that. So that's an important facet of what we do. There are so many disciplines that come to Smpte that we can't forget about the electronic film industry. Certainly it was the industry of acetate at one time, and it's not, because that, for all of and good reasons, has now emerged or reemerged into electronic cinematography with a lot of manufacturers, but there's still a great population that's shooting film style, and I'm not talking about red cameras, I'm talking about film style, expensive, detailed, high pieces of technology. Not that there's anything wrong with red, don't get me wrong, but I'm talking about electronic cinematography in its full version. So we want a technology group. We want a subcommittee for that, number one. And I think probably another very important thing is we want to put together a post-NAB review from people that are here, people that are going to NAB that want to talk about what they saw, what they like, what they think is emerging. So I don't want it to all be driven, or these meetings, in the case of Florida, to dais here because contributed food. Nothing wrong with that. That's a great thing. Thank you, Harmonic. Thank you, Teradek. However, we put together our own group here, some great presenters, and talk about their technology, their ideas, their vision, their direction, and I think we're going to get a lot out of it. A lot of talented people, not only here in this room tonight, but as part of our membership, and a lot of talented people in Florida and elsewhere as a whole. So does that sound like something you'd like to do? Something, yeah? I see a lot of heads nodding, but I don't see enough. How about a show of hands, because you might be a little tired. Okay, so we got 2, 3. There you go. Nice. All right. So feeling here that this is something to do. I don't know if you're shy with email or not, but can you please email me? I want to put together some committees. Is there anyone here that doesn't know how to get a hold of me? You should know how to get, well, did you get a letter by any chance? You did not. Are you a member of our Facebook? So you're going to do that tonight, right? Probably, because the full sale group has been sharing all the photos that's been posted tonight. So what you do want to do is you want to join that. You're going to find my email address in the rundown left-hand corner, and you're going to send me your information saying I would like to serve on a subcommittee for X. I want to be on the post technology subcommittee. I want to be on the emerging technology committee, which is also nobody here. We might be able to improve on it, but we're not inventing it, number one. And certainly this, a lot of bright, energetic minds like yourself. Yes, sir. That I mentioned, but I wanted to throw that. There are other ideas. So we want a technology, emerging technologies, or a technology subcommittee, which I think is very major tum to where, whatever. Anyways, so we want that. That's very important. And we want new visionary, and we want some other ideas. Sorry? I know that sound that came out here didn't come from the Venetian blinds. Did somebody just suggest something? Seriously? I must have heard something. Please, ideas, volunteerism, important. There is not one manager here in your Smpte group that gets paid one dime or takes one penny from the coffers of this group or elsewhere. Nobody gets any reciprocal from a manufacturer. Nobody gets any gratuity from anybody. We do this because it's our life and our passion and our drive. We want you to be part of that as well. That's important for you to stay engaged. For the young from Full Sail. You know, it all started off for some of these people here in the 50,000 watt or the 5,000 watt radio station in Oshkosh, Wisconsin. And I'm only kidding, but it started very small for a lot of people here. And then the next thing you know, 30 years later, 40 years later, 50 years later, you're dealing with technologies at the top level. But it doesn't happen tomorrow. You don't walk out of school and say, okay, I'm ready to direct. I want to produce my feature film. Where are you? So it takes a while. But groups like this, we become your, we help you build. We help you grow. We help educate you. Everyone in this room started off somewhere dreaming about, I'd like to get into this industry. Not a bad idea. Not a bad idea. So continue to keep doing this. Continue to keep coming. Continue to keep growing. Continue to keep your vision in our minds, because you replace us someday. You do. In a very short period of time, believe it or not. You know, time goes by rather quickly. Yeah. Anyway, very important. So I want to take my passion that I have for this industry and this technology and this group and the love for all of this, give it to you, have you give it back to me. Let's get people involved. Let's not make it all top down. Let's make it your section. This is your group. Okay? Fair enough? Love it. Thank you so much for attending tonight. And we'll be seeing you post-NAB. That'll be our very next meeting. And we have Grass Valley that's already come to us, said, please pick me, pick me, pick me. So I know one of the subjects is going to be HDR, okay? Thank you.